How to help ladies live long and prosper. Associations between epigenetic age acceleration, a biomarker associated with aging, and healthy longevity among older women. Cool science. So what? In this study, the epigenetic age acceleration of older women was found to be associated with a lesser chance of being alive at age 90 and retaining full cognitive and physical function. This is my summary of analysis of epigenetic age acceleration and healthy longevity among older U.S. women. Here's some background. Every human ages differently than each other, but often similarly to their ancestors. Some elderly people are considerably healthier than expected, with superior physical and cognitive performance in their senior years, while others tend to decline at a younger age. Growing evidence supports the theory that there might be a divergence between biological and chronological aging, and this separation has been connected to changes in DNA methylation patterns, or biochemical modifications, that occur with time. These variations in DNA methylation patterns have emerged as a biomarker for biological aging and are referred to as epigenetic aging. When epigenetic aging accelerates, people seem older at a given chronological age, a phenomenon known as epigenetic age acceleration, or EAA. The purpose of this study was to look at the links between EAA and a good lifespan in older women. So here's the hypothesis. In this cohort study, in 1,813 patients from the Women's Health Initiative study, genome-wide DNA methylation analysis was performed on participant blood samples to assess epigenetic aging. The following outcomes were examined for associations with EAA. Survival to age 90 with intact mobility and cognition, survival to age 90 with impaired mobility and cognition, and not surviving to age 90. Intact mobility was defined as little to no self-reported limitations for walking one block and climbing one flight of stairs. Cognitive functioning was assessed annually during the follow-up, and any cases of self-reported moderate to severe memory problems or a diagnosis of Alzheimer's disease or dementia classified as cognitive impairment. All right, so here are the results. Of the entire 1,813-person cohort, 464 of the participants survived to age 90 with intact mobility and cognitive function. 420 participants survived to age 90 without intact mobility and cognitive function, and 929 unfortunately did not survive to age 90. The participants in the cohort who made it to age 90 years with intact cognitive function and mobility tended to be healthier at baseline compared to those who survived to age 90 without intact mobility and cognitive functions, or those who did not survive to 90 years old. When associations between the epigenetic age acceleration were examined relative to the study outcomes, the data revealed that the EAA was associated with reduced odds of surviving to age 90 and intact mobility and cognitive function. Women surviving with healthy longevity were also more likely to be college graduates, have no history of smoking, walk 2 to 3 times per week or 4 to 6 times per week, have a BMI in the reference or overweight range, and have more than 1 but fewer than 7 alcoholic drinks per week. The authors concluded that, based on their results, the epigenetic age acceleration may be a helpful biomarker for estimating cognitive and functional aging in older women, which may guide future interventions designed to reduce disease risk and increase longevity. The goal now would be to test interventions that lower this epigenetic age acceleration, which we could then believe with some significant confidence that these interventions could then extend a life of quality. Now notice I did post figure 2 from the study that's a force plots of the association of EAA measures and healthy longevity. Here, the epigenetic acceleration measurements show measurable increases in biological aging that is associated with increased odds of poor health outcomes at age 90. Notice how the categories on the right, figure 2B and 2D, cross a line at 1, which indicates an increased likelihood of the measured outcome, which would be decreased mobility and decreased cognitive function, or both. Some limitations. The study has several strengths with a diverse, large, and closely followed population, but my gripe with many aging clocks are the common low R squared values. R squared measures how correlated two variables are, and these types of clocks typically have statistically significant but low correlations. This tells me that these variables are related weakly and serve best as signals but not as causative targets. In genomics, this is usually a statistical power issue, and having a larger population size can help, but it can also mean there are more variables that need to be measured and accounted for to tie the variables closer together. Of course, both of these problems are likely at play since aging is not a simple biologic process. I have faith that with growing population and more complex models are made, tighter correlations will be found. Having tighter correlations can then help in finding interventions that have larger effect in controlling biological age.